Okay, hi. Hi, everyone. So I'm Philipp from the DeSci Foundation and from DeSci Labs. And I want to say a couple of words today about science as a public good and how impact certificates may actually help us to finance science and research more effectively than we're currently doing it. And just as a warning, what I'm going to talk about are not final solutions. So you will see that there's a lot of opportunities, but there's also a really huge design space. So there's a lot of things that we need to figure out. So rather than presenting final solutions, I really just want to get a discussion started on this. And I want to start by giving a huge shout out to our friends at Protocol Labs, and in particular to Juan Benet, who actually made us start thinking about using impact certificates when we first talked to him about DeSci and the system that we're building. So let's start with some basics. So just as a brief reminder, in economics, we actually define a public good as a good that is non-excludable and non-rivalrous. And science and research are primary examples of public goods. So, right? So if you think of something like calculus, I can stop you from using calculus. And if I use calculus, it doesn't reduce your value of using calculus in any way. But that actually brings a problem with it because traditional market mechanisms where you actually want to charge people for the usage of a good don't really work well. And we end up providing fewer public goods than what is socially optimal. And as a result, public goods, they often depend on government interventions and on altruism to be provided. So of course, this is actually what's going on at the moment. So we have mostly government sponsorship and altruistic sponsors and foundations actually funding a lot of the basic research that is going on. But the problem is that the current funding systems are far from optimal, right? So there's a large degree of inefficiency. And this is actually where impact certificates can come in. So the basic idea of an impact certificate is of course, that it is much easier to determine what was impactful and what should be rewarded after it has been carried out, right? So in retrospect, you have a lot more information and that enables you to make much smarter decisions about where to put the money. And so technically speaking, an impact certificate is a fungible, transferable, tokenized certificate that facilitates allocating retrospective rewards, and it supports hierarchies of credit assignment and should be open to various mechanisms. And then there's also this idea that as the owner of an impact certificate, you can actually burn your claims for financial future rewards in order to get like the ultimate reputation gain, right? And science is a fantastic application for impact certificates. So in contrast to a lot of other public goods that we want to finance, science actually doesn't have some of the design problems that we have with other public goods. So for example, research projects and publications, they typically claim a very well-defined contribution space. So there's no discussion about what is actually being claimed. And we have a very well-established auditing mechanism for basically proving the uniqueness and the quality of science. And that is, of course, peer review. And peer review is, of course, far from being perfect, but at least it's an established system that we can build on and that we can improve upon. We also have well-established norms regarding authorship claims and credit attribution to funders and prior work. And finally, an important issue here is also the question, so how do we measure impact? And of course, in science, we have various measures to do that. The most important currency is, of course, authorship and citations. And although all these quantitative proxies of impact, they're far from perfect, at least we're not starting from zero, right? So we can build upon these things that already exist. Okay, so looking at the design space, the first question is who is actually going to put up the money for that? And I would say that we can broadly differentiate between two categories. So we have, on the one hand, we have the retroactive funders. So these are going to be people and institutions that are putting money up that will be retroactively distributed to the holders of impact certificates. And I would call these people and institutions primarily impact funders because they're going into this not with a profit incentive, but primarily with the incentive to just sponsor science and to get impactful science, right? And then you have the buyers of the impact certificates, and that's not necessarily a completely disjunct group of people or institutions, right? So it's totally possible that you have some institutions or some funders that are actually acting on both sides of the market. But as impact certificate buyers, you can also think of normal people like you and I who can actually make a statement that this is a particular piece of research that we care about and we can support it, right? And you can also think about institutional investors who come in and who buy these impact certificates with a profit incentive, basically trying to buy them at a lower price than they could ultimately sell them for or be rewarded for. So who gets what? The impact certificate buyers, they obviously get reputation and the potential for financial returns in the future. The researchers, they actually, we can make them participate in the financial returns. And like the researchers by themselves, we don't need the impact certificate for them to claim credit for the work that they're doing, because that is already done through the authorship on the paper or whatever they're doing. So that is not really a concern, but there is still a very good reason to give them sort of partial co-ownership in the impact certificates. And that is because we want to align the incentives of the scientists and the funders to alleviate principal agent problems, right? And that actually opens up a lot of possibilities for reducing auditing and overheads that comes with traditional financing mechanisms for science. And it also opens up the possibility for scientists to actually earn additional money. And some of them, they may actually make enough from these impact certificates that they can be independent. And that brings up the idea of having a flexible cap table with tradable shares for impact certificates. So this would be very similar to a company where you basically have shares to quantify how much of an impact certificate or a company is being owned by whom. And then the owners, they can sell their shares. And you may also have a mechanism where you do capital raises by just issuing new shares that lead to a dilution of the ownership of the previous owners. And that would actually create the possibility to raise additional capital later and options to opt out for financial rewards for ultimate reputation gains. And that could be done very flexibly by each owner of that impact certificate individually. So that's actually a super powerful mechanism that is very well proven in markets. And it would just be super cool if we could bring something like that to finance science as well. And then there is the question, so how would you actually have a fair distribution of share ownership among the scientists and the funders, right? And the basic principle here should probably be that marginal rewards should be equal to marginal contribution. And if you take that starting point, then you come up with a number of conclusions that you arrive to. So for example, you would conclude that early stage investors who have a much higher risk by investing into the project early, they should get higher equity shares per dollar invested than later stage investors, right? And so on and so forth. And then there's this big question, so how do we actually measure impact and when do we do that? So my sense is that there is probably not going to be one approach that is going to be optimal for everything. Probably we need pluralistic approaches where we experiment with different ways of actually quantifying impact and ranking the impact of different projects. But besides from algorithmic approaches, there's also an alternative approach where you say, well, we should just leave it up to the preferences of the funders, and it should be them who ultimately decide what they think was impactful and important, right? So you can think of a funding mechanism that uses quadratic retroactive funding here. So what are the incentives? So once you have the impact certificates and you have a large pre-committed fund for retroactive rewards, you actually create incentives for other people to provide grants and prizes and other forms of investments into future research. And the impact funders, those that actually put up the retroactive rewards, they have a pretty big incentive to use this mechanism because they ultimately will get a much bigger bang for the buck, right? So they can actually spend their money much more efficiently. And that's because they can actually have co-investments from other parties. So through crowdfunding, they sort of also have this guarantee that a part of their funds, at least, will be allocated very efficiently based on information about what actually worked. And because we can actually solve this principal agent problem to some extent, it reduces the need for overhead and monitoring. And finally, because everything is going to be on the blockchain, we have this, this beautiful and open data about who did what and how, we can actually have very detailed information about the impact of these investments, which is what these funders ultimately care about. So the investors in the impact certificates, of course, they would also get reputation and potential financial rewards. And for the scientists, they would get new sources of funding for their research, and again, reputation. And actually, this is also quite important, rewards for doing open, high-impact science. So now I'm just going to give you two examples of how this may work in practice. So the first one is what we call open science certificates. So the idea of an OSC is not that you finance the underlying research, but you rather finance the process of making the results of the research openly and publicly available, and for evaluating the quality of it. So basically, an OSC verifies that a scientist has created a valuable, fully open scientific contribution. So the purchase price of an OSC could cover things like the costs of peer review, so rewarding peer reviewers for the work that they're doing. It could also cover storage and gas fees, and it may also contribute to an open source development pool that could be used for financing the ecosystem. And this is actually a pretty cool mechanism how we can bootstrap a truly open science economy. And these open science certificates, they would actually be really valuable to researchers because scientists from around the globe, they're actually being put under quite a lot of pressure to publish their work in open science journals. And also, so that there is a lot of pressure like from funders, from the public, but also from their employers for very, very good reasons. And by having this mechanism, we could actually, we could go a far step beyond just putting your work in an open access journal and paying a publication fee. We would literally not need a publication fee. We would make everything open from the beginning. So what is the process? So people would just go on our platform and they would create what we call a DeSci node. So that's a research object where you can store the manuscript, the data, the code, where you can also have videos, annotations, all different other sorts of supporting information. You make it fully publicly available, and it's going to be stored decentrally on IPFS and Filecoin. And then a qualified community of independent scientists, they conduct in-depth peer review, and they reward their referees for the work that they're doing. And in our system, this would be done in what we call ARCs, or autonomous research communities. As a third step, the original nodes that meet open science standards, they would then receive an open science certificate, and then investors, sponsors, or collectors, they can buy these things. And those of the owners of the OSCs that are potentially not interested in financial rewards, they can opt out of them and become permanent named sponsors of that OSC. And then as a final step, you would have an oracle of retroactive funders that reward the owners of the open science certificates. And we could organize this, for example, through a DAO with quadratic funding. And as a second example, we could actually also combine the classic funding instrument of grants with impact certificates. So this example here would be a lot more difficult to implement. It's much more complex, but it also has a lot of advantages. It basically ticks a lot of the boxes that funders and scientists have in mind. It would create a lot of opportunities for basically closing the liquidity gap and for giving the impact funders the opportunity to also claim full causal credit for the work that they have funded, even though they've been using a retroactive funding mechanism. So how would this work? So first thing is a funding pool is open. So this could be general purpose, or it could be dedicated to a particular research topic or field. And then you open the pool and you make crowdfunding possible. And then a part of the funding pool would get reserved for retroactive funding, and the other part would actually be given out in the form of grants to scientists and to teams that are applying for this. And here at this third point, the funders can actually decide if they want to decide which proposals they want to sponsor, or they can completely outsource that entire decision-making process to an ARC that would review the proposals and allocate the funds. And at this point, we would have a lot of opportunities to experiment with more efficient ways to allocate grants, right? So one thing you could do here is, rather than what we're currently having in our current system, where you typically give out relatively large grants to a small number of people. So like grant funding rates are usually like around 10% of the applications, which is really, really low. So instead, what you could do is you could give out a lot of micro grants to basically allow a lot of different groups to start experimenting with their ideas. And then additional funders can come in and they can invest into the projects by buying shares in these impact certificates on the marketplace. And the most promising projects at that point, they would get additional funds and initial investments of the impact funders would be leveraged. And then finally, an Oracle would reward later stage buyers of the impact certificate share owners. So the good investors, they would make a profit, and the impact investors, they could opt out of the financial rewards and become permanent named sponsors of that research. So these are some starting points, some ideas that we're currently toying around with. This is all work in progress. We'd love you guys to join us. This is our QR code here for the Discord. So hop on the Discord, join our discussions, and help us build this. Thanks.
Is there any questions?
So thanks for the talk. I must say that DeSci is interesting as a whole. And in particular, what interests me is the new metric you're introducing to this world. Coming from some years in the academia, I see that the main metric for value of a paper or research is probably the H-index of the author or either the number of citations. And right now you're introducing this IC or OSCs that have some value in the DeFi market. And can you try to explain how does this not compromise the true value that was defined before DeSci?
Right. So, I mean, the big question is, what is the true value, right? So how do you determine that? And I think this is really the big question that we have to resolve. So the current metrics that people are using, such as, in which journal have you published? So what's the impact factor of that journal? How many citations does your paper get? These are all like rough proxies for how important that idea was relative to other ideas in the same field. But these metrics, they're problematic because, for example, they do not take into account whether the work that was published is actually reproducible and replicable, right? So one thing we could actually think about is if we want to stick with the traditional metrics, and if we would take them as, potential indicators of true value, we could combine them with markers of replicability and reproducibility, which we can actually also generate in these nodes and have them basically verified through peer review in our system. So that is one approach. And the other thing is also like what the ultimate value of research is probably not an objective criterion to begin with, right? So, I mean, if you're suffering from cancer, then any research that is related to curing your disease is much more important to you than any other research, right? So there's also something to be said here that it should be ultimately the funders who decide what is actually impactful and meaningful to them. So I would see that as complementary approaches, and I'm arguing for various for a plurality of different approaches to measure impact.
Yeah, thanks a lot, Philipp. So Martin Kodar is my name. I'm working on a project called Fleming Protocol. We're involved at the kind of patient side of this, where we want to pull biomedical innovation from the academic domain, and we see the patient groups as possible funders for these types of projects. But how do you see this type of a situation integrating with the existing intellectual property situation, so the traditional patent situation and the kind of trade secret side of things as well?
Yeah. So I think there is an obvious conflict between doing science totally openly and doing it under an IP regime where one particular entity actually owns the property and can license it out and basically has a temporary monopoly, right? So in a way, so this entire IP mechanism is sort of like it's a broken crutch to solve the public goods problem that we're having, because instead of actually solving the problem, it introduces a new one, which is that yes, you basically give an incentive for people to develop these things, but you're doing it at the cost of creating a temporary monopoly that is going to be awfully exploited, right? So I think there's obviously a conflict between these two things. However, so I completely understand that IPs will remain to be an important mechanism, so especially in pharma and so on and so forth. So I don't think that it's going to go away. But what could happen is that you sort of have agents or companies that are starting to use these impact certificates to sort of incentivize basic research that they think is necessary to be conducted before they can actually do research at the IP stage. So they can use that for basically outsourcing part of their research that they don't think is necessarily applicable to IP. Exactly. Yeah.
Any other questions? No? Thank you.
Thank you all.